In this video, we are going to prove our first irrational number. So we will prove that square root 2 is an irrational number. So that is the question. Prove that square root 2 is an irrational number. So that is what we want to prove. And in order to prove this one, we will use proof by contradiction. So in order to prove proof by contradiction, we will start with an assumption, and finally we come up to a point where we definitely know that thing is wrong. So when we come to that point, we definitely know that our assumption must be wrong. Okay. So here we can apply proof by contradiction because there are only two possibilities of square root 2. Either square root 2 can be an irrational number or square root 2 can be a rational number. Okay. Since there are only two possibilities, we can apply proof by contradiction. Alright. Okay. So since we have to prove square root 2 is an irrational number, we will start with an assumption saying that square root 2 is a rational number. Okay. So this is our assumption. So assumption here is that square root 2 is a rational number. Okay. So we will start off with this one. So square root 2 is a rational number. So if square root 2 is a rational number, so what is the definition of rational number? That any number which can be expressed in the form of p by q. So such numbers we call it as rational numbers, which means I should be able to express even square root 2 as a fraction. So let square root 2 be written as some fraction a by b, and a by b is in the simplest form. So what does that mean, simplest form? Which means you cannot divide it further. This is the most important argument here. Okay, so where a and b are, we write it as co-primes. So what are the definition of co-prime? Co-prime means there are no other divisors of a and b. Okay, which means this is already in the simplest form. Since it's already in the simplest form, there should not exist any other divisors which divides both a and b. Okay, so where a and b are co-primes. Another way of saying this is that HCF of a and b is 1. So if HCF of a and b is 1, what does that mean? Which means that also again means that there are no other common factors between a and b, which means there do not exist any number which divides a and b. I will write in the first statement for you. That is, co-prime means there do not exist any number which divides both a and b. So that's what co-prime means. So you can write co-primes also as HCF of a and b as 1. That is also okay. Okay. So this is the argument that we are making. So when I say square root 2 is in the simplest form a by b, so that means that there do not exist any other number which divides a and b. Alright. Okay. So let's simplify this one then. So once I start simplifying, what happens now? So square on both the sides. So let's call this as equation 1. So square on both the sides. Square in 1, square on both the sides. So when we do that, what happens? Square root 2 whole square becomes 2, and a by b whole square becomes a square by b square. So this means that I'll simplify this one. What happens? I'll bring this b square this side. So a square becomes 2 times b square. So here what is it saying? A square is 2 times b square, which means a square is some multiple of 2. So if a square is some multiple of 2, so from this I can say this implies 2 divides a square. Correct? So if 2 divides a square, so one of the theorems we studied just now in previous videos, that if p divides a square, p also divides a. So if 2 divides a square, this also implies 2 divides a. I hope you understood this one. So what did we say here? From this one we got a square is 2 times b square, which means it is some multiple of 2. A square is some multiple of 2, which means 2 obviously must divide a square. And by the theorem that we studied, that if p divides a square, then p also divides a. If 2 divides a square, then 2 also divides a. So we got one number 2 which divides a. So since 2 divides a, which means a is some multiple of 2, we'll make this assumption. So let a be some 2 times k, because it is some multiple of 2. Correct? And then what I do, I'll substitute. Okay, so let's call this as 2. I'll substitute 3 in 2. This is 3. So substitute 3 in 2. Now let's see what happens. A, I am substituting it as some 2 times k. So if I substitute here, this becomes 2k whole square is equal to 2b square. So this is 4k square is equal to 2b square. 2 1s are 2 2s are. So b square is equal to 2k square. Now what are we saying here? B square is again some multiple of 2. So if b square is again some multiple of 2, I can again say that this implies 2 divides b square. Again by using the theorem that if p divides some a square, p also divides a, which means if 2 divides b square, this also implies 2 divides b. Remember, what was the argument that we started off with? We started off with the argument that there do not exist any number which divides both a and b. Now we have come up to a place where we know that 2 divides a, 2 also divides b, which means 2 divides both a and b, which is not possible because we started with an argument saying that there are no other number which divides a and b. And finally we are saying 2 divides actually a and b, which is wrong. Correct? Since 2 divides both a and b cannot be true, our assumption must be wrong. So what was our assumption? Our assumption was square root 2 is a rational number. So if that assumption must be wrong, therefore cannot be true, square root 2 cannot be a rational number. Since it cannot be a rational number, we can say that square root 2, therefore square root 2 is an irrational number. Simple proof. I'll repeat it once again for you since this is the first problem that we are solving in irrational. So we started off with assumption saying that square root 2 is a rational number which is in the form a by b. The argument here is that a by b is in its simplest form. It is in the simplest form means there are no other numbers which divides a and b. So once we square this one, we got a square is 2 times b square, which means a square is some multiple of 2, which means 2 must divide a square. So if 2 must divides a square, by theorem 2 also divides a. So if 2 divides a, now I can write it as a as some multiple of 2. So a I can write it as 2k and I'll substitute this 2k in this equation. So once I do that one, I'll get b square as 2k square. Again we are saying b square is some multiple of 2, which means 2 must also divide b square. If 2 divides b square, 2 also divides b. We started up with the argument saying that there are no numbers which divides, there is no number which divides both a and b. But here we are saying that 2 divides a as well as b, which must be wrong. So if we came to a point where we know that is definitely not possible. So which means what must be wrong? Our assumption must be wrong. So square root 2 is a rational number must be wrong, which means square root 2 must be an irrational number. I hope you understood this.